Okay, yeah, this class will not be the death of you. That was how we're starting today's lesson. All right, today we're going to practice using the chain rule. Yay! Did you guys do these? Let's get this. Okay, who wants to volunteer? You want to do the second one? Oh, wait, you're doing the second one? You want to? What do you want to do? All right, tell me. Yeah. All right, guys. Jessica's telling us this first one. Where are you getting the 15 from? Yeah, she's using the power rule. 5 times 3 is 15. Tell me what the new exponent is first. 4. Okay, and then what goes inside? Correct. We don't change the inside function. Then what do you multiply that by? What? Does anybody agree with this? Like, calculate. It's really long.
Is it the sign of the angle x plus 1? Should there be parentheses or x plus 1?
Oh, it's not sine of x plus 1. It's just sine of x. If you don't see parentheses, you're only taking just the x is the angle or the argument. Yeah. Then this is right. Yeah. Good job. Good job. All right. Now, Audrey, you said you wanted to do the second one? Okay. Now, are you going to do it using substitution or by multiplying derivatives? Either way is fine. Okay. So tell me what you did. Oh, okay. You're doing it the crazy way, the cool way. Okay. So what did you get for this derivative? Okay. Now, I just want to know what we should call this derivative. dy du, right? Because it's y is a function of u instead of x, so it's dy du. And what about the other one? I can't believe you did this way. I'm impressed. All right. And what is that? 3x squared minus 2. So she got each of the derivatives separately. Okay. Yeah, because when you multiply dy du by du dx, what do you get? Yeah. Times, I just want to write it out. So if you want dy dx, you multiply dy du by du dx. So you said you multiplied them. You got 2u times 3x squared minus 2. Yeah, then you substitute u in. So we're putting in for u the x cubed minus 2x. And we have the 3x squared minus 2. Bless you. That's great. Mm-hmm. So I'm surprised that she did it that way, but I just want you guys to be able to follow doing it that way, so you can get the derivatives separately and multiply them to get dy dx. All right, did anyone do it by just first substituting and then get the derivative? All right, Ryan, what'd you get? So you substituted in for u first? Okay. Nice. And then you took the derivative. Okay. And when you use the chain rule, because it's a composition of functions, what'd you get? 2x cubed minus 2x to the first, so you don't have to write it. I know you weren't there, but I just want to make sure people don't forget the exponent. So use the power rule on the outer function, and then times the derivative of the inside function, 3x squared minus 2. Same answer. So either way, it's just great. You love it? Okay. Now, I know the homework, I think some of the I know a lot of people were complaining about some of them, but maybe it was more the wording or the fact that they use different letters. So I want to see what questions you want to go over. I'd like to go over a bunch of those. 27. 27, we agree is a good one? Okay. So I'm going to start with 27. No one's supposed to read that stuff. Okay. Okay, this is 27. Square root of theta sine theta. They're reading ahead in the notes. Okay, well, we're not going to leave it like this, right? Square root. Yeah. Okay. First, so wait, you asked for 27, right?
Yeah.
Okay. So the first thing, you wouldn't leave a square root. You'd replace that with the exponent would have, right? Yeah. No, you wouldn't leave it that way, right? Yeah. Okay. So did you now when you take the derivative, we don't have y as a function of x. We have r as a function of theta. So instead of x's, we have thetas. Instead of y, we have r. So what am I going to call the derivative? Nice. So theta is just like your x here, okay? And r is like your y. Now, what did you get the derivative of the outer layer? Okay. We're going to copy in a second. What's the new exponent going to be? Nice. And we never touched the inside function. Okay. But now we have to take the derivative of the inside, and you look at that inside, and what is it? Yeah, but say it again. It's a product. So we got to use the product rule. Oh, give me a break. This is one rule inside another. This is not a big deal. You guys are much tougher than that. You know? Okay, everybody would ask you is tougher. This is just product rule. All right, so how did that product rule go again? All right, what's your first? What's the derivative of the second? Mm-hmm. You know what I'm thinking after today? I got to do a little quiz on the differentiation rules.
I think you should do that.
Yeah, that's just you. Everyone else says, do it. We want that. All right, so we got first times derivative of the second plus second. The derivative of the first, we have thetas instead of x. Theta is not a constant. It's a variable. So what's its derivative? 1. Is that what messed you up?
Yeah.
Oh. Yeah. Mm.
So is that it?
Yeah, that's it. Yeah. Correct. I mean, if you look it up in the back of the book, they might, instead of having this theta sine theta to negative a half, they might just have a square root of it in the denominator. Yeah. Yeah, it's what it's the variable we use when for angles a lot of times. No, there's nothing wrong with theta. It's a letter. It's a Greek letter. Alpha's good. Alpha's a good one. What other one you want to go over?
1 to 33.
Okay, I'm next. Jen. 23. Y equals 1 whole squared. Oh, we got to change that. 7x. Oh man, there are no parentheses. I can't even, don't even think about using the chain rule until you fix this up. Okay, so we need to fix this up with some parentheses. All right, now, first of all, we said you always want to have parentheses around your angle, and you never want to leave an exponent on a trig function. Well, it's going to confuse you. So, I mean, this part's fine, the cube. But tell me what to write next. Parentheses. Because what's being squared is the cosine of 7x. Yeah, unless the angle is just x, you need to put parentheses around it, because then it's a function of x. I'm going to do it in red, because I can. No, just stick with gray or whatever you're writing in, whatever sad color you're writing in. All right, so now we can take the derivative. We're ready, right? All right, outermost function, the 3, that cubing, right? So we're going to use the power rule to begin with. So when you take the derivative of something cubed, you get 3. We're going to leave the inside alone. What's the new exponent? Squared. Now I'm going to fill this in. So 1 plus, and you can write it as cos squared 7x, you know, when you're filling in the inside, but I'll just leave it. All right, So check, we took the derivative of the outermost layer, right? You don't have to do that. Now, we want to take the derivative of the inside. Well, the inside is a sum. It's 1 plus something else. So to take the derivative of the sum, you take the derivative of each term. So I'll take the derivative of the 1. Okay, good. And then now we get to the second term. We got to take the derivative. Oh, we got to go back to the chain rule, right? So where are we going to start with taking the derivative of cosine of 7x squared? 2. So it's 2. We're going to leave the inside alone for the first. So it's a cosine of 7x. Now, okay, so we did that. But times, we took care of the squared, but we go in, yeah, derivative of cosine of an angle is negative sine of that angle. Negative sine, and right, we don't change the inside function. So we took care of the derivative of cosine, but yeah, we still have to go in one more layer. 7. That's a times. You know, and I think I would multiply the 3, the 2, the negative, and the 7. Like all the constants I put out front. You know, you got 3 times 2 times negative 1 times 7. I would write that as a negative 42 out front. Yeah, but then everything else is the same. Like you can leave that, you know, the 1 plus cos squared of 7x. Oh, squared. You can leave the cosine of 7x and the sine of 7x. Good? Other questions? Yes. 31. Cotan of 3x minus 1. Oh, wait, is this one that said second derivative? Oh, that's why. Okay. Cotan of 3x minus 1. Okay. So we'll get the first derivative. We'll use our chain rule. The outer function's cotan. Do you remember what the derivative of cotan is of an angle? Negative. Good. Negative secant squared, and we're going to leave the angle the same. So 3x minus 1. That's the derivative of the cotan. Then we multiply that by the derivative of the inside. 3. So I'm just going to write it, since I have to work with it, I'm just going to write this as negative 3 cosecant squared of 3x minus 1. Since I have to take the derivative again, what's being squared? The whole thing, the cosecant. I'm going to rewrite it before I try taking the derivative. Just make sure you agree with that rewrite. I don't want to leave that squared here. So I open the parentheses in front of the trig function, and I close it after the angle. That's what's being squared. So there's our first derivative. Now we want to take the derivative of that. So do you remember what it looks like when you write the second derivative? Like there's some weird, like, all right, just tell me where the squared goes in the numerator. Okay, after the d, in the denominator. Oh, good. Okay, so, we got a composition of functions. We're going to use the chain rule. So what should we do first? The outside. So we have the power rule. So 2 times negative 3, negative 6. We're going to leave the inside alone. And what's the new exponent going to be? 1. So we're going to leave that cosecant of 3x minus 1 inside. So we took the derivative of the outermost function. Now what's the next one? Is negative cosecant of the angle, cotan of the angle. All right. So cotan of 3x minus 1. Whew. All right, now we got to clean it up all over again. All right, so what's the coefficient? It's positive 18 because we have negative 6 times negative 1 times 3. So that's positive 18. Can we do anything else? Yeah, cosecant squared of 3x minus 1. And then we still have a cotan of 3x minus 1. All right, so that's better. All right. Other questions? Anyone bothered by anything else? No? Do you want to try that, the bad boy I have here? Let's try this bad boy. There you do. I'm surprised no one said, no, I don't want to see it. This is such a nice class. You feeling sick because of this problem? Hmm? Oh, all right. What would you do, like, other than give up or run away? What's the first thing, Cameron? Mm-hmm. Yes, you have to take the time to set the prep work. You know, any of you that have ever painted, you know, it's all in the prep work. Yeah. So we're going to take secant of 3x squared all to the half. The denominator is lovely. Nothing wrong with that denominator. Okay. Now we're ready. What do we just do? Start looking randomly and just taking derivatives of stuff? Yeah? Okay, that's what we should do. No. You have to say, all right, this is a quotient, so I'm going to use the quotient rule. All right? You got to always have a plan when you take the derivative. So we're starting low. Here we go. That was well done. All right, so I guess I'm just going to put this. I'm never going to finish my numerator in one line. I never do. All right, so here we go, guys. Low. We write the denominator. Ooh. D high. Got to use the chain rule. Yeah, probably still won't fit. Okay. Secant of 3x squared to the negative 1/2. So we use the power rule. Okay, we go in a layer. Now we're up to, we go inside. We got the secant, right? What's the derivative of the secant of an angle? Secant of the angle. So we keep that angle. So it's secant of 3x squared. Tan of 3x squared. So it's secant of the angle, tan of the angle. Right, then we go into the 3x squared times 6x. Oh my gosh, so what do we have so far? We've got our low. Okay, that's good. And all this is d high. It's just the derivative of the numerator. So we're not even done with the numerator. What comes next? Less. We got the minus sign in there. Oops. Okay. So minus high, we're going to write the numerator. Aw, D-low's cute. Okay. D-low. So it'll be times 2x to the 5th minus x plus 3 all to the first power. Right. Times 10x, oh wait, 10x what? To the 4th minus 1. Right, so what we have so far, we had low D high, less, this is our high, and we did the D, so we took the chain rule for D low. And D high. Did I? Oh. Oh, okay, so, oh, I was looking at that thing. So 1/2 secant. Okay, I'm still not sure where I did that. Oh, here. Yeah, when I was copying, I didn't see it. Thank you. And you diagnosed it correctly. So are we finished? Nope. So the denominator squared, it's already something squared, so when you square it, You forced it. You forced it. 2x minus x plus 3. You forced it. It's done. Put a fork in. So if you put parentheses around like the whole numerator, you're saying? Because that would be a smart idea since we're carrying on. But oh no, not there though. All right, sorry. Where if you put parentheses? Squared squared. Lame-o, squared squared. Yeah. It's just like someone's reading it, they're like, oh, when they see that, they're like, oh, look what you did. It's just awkward, It's awkward. Okay, now, what we're going to do for the rest, you guys actually have 10 minutes to get a start on the homework. It's 12 problems. Yeah, the sheet that says homework. I had a lot of people coming up to me and saying, is this the homework? And it says homework on it. No. It's, they just got it. They got to be sure. So, yeah, you might, if you have any questions, I'm just going to roam around and help you. So, people at home, see ya. I can't come over there and help